but that's not what I'm here to talk about today, right? So digital transformation. We know that all over the world, I mean, we are kind of living in an era where everything is getting transformed digitally, right? I mean, there's digital disruption in every aspect of what we do today. So thinking from, I mean, how much we use our phone to do everything from booking a flight ticket to going there, Ubers, Digi Yatra, our face gets scanned, we go in there, our watches, everything is getting transformed. So wanted to quickly take a look at what are we doing as a AEC industry in construction and in design. All right, so this graph on the right-hand side, it shows various different industries and how digitally ready we are, right? I mean, if you see the IT sector and media and professional services, they are all on top. Green means you're kind of digitally ready, and red means you're not there. Orange is like, you're kind of getting there. This is from a few years ago, but if you see construction, it's like second from the bottom right now. And the only thing below it is agriculture. And we know that some of these things have kind of moved up. I know construction is also kind of moving up, like that mentioned. There's some things coming up. But there's a long, long way to go before we can think ourselves as an AEC industry where we are using technology as and when it should be used. McKinsey had come up with a report, which on the left-hand side you'll see that most of the projects, they typically take 20% more time to finish, and budgets, about 80% of the project, I think the budgets are busted. So there is a kind of a need for that, and the construction industry is ripe for disruption. And we've kind of started moving in that direction, I think. This is a very interesting slide from the future of construction. This was put together by the Boston Consulting Group. And there's a lot of things here that you'll see that somewhere or the other we have kind of started doing that world over, maybe not everything in India yet, but from prefabrication, advanced building materials that we just heard about, 3D printing and additive materials, additive manufacturing, autonomous construction, there's AR and VR that's being used more and more, big data, predictive analytics, with wireless monitoring, connected equipments, cloud and real-time collaboration, and building information modeling. So there's a lot of things that are happening here, but when it comes down to it, all of that depends on data. And data is where we, as design professionals, can bring value on. If we don't have our data right, if we don't have our models correctly, none of these other things could work. There's a lot of dependency on what we do. So I think the time is right to rethink on how we design and deliver projects, and that's what I'm going to talk about today just a little bit. Being an engineer, I'm going to just kind of focus on the design aspect of it. We'll talk about construction a little bit later in the panel today as well. Okay, so what is the need for it? So these are two, let's call them similar projects, very similar kind of structures. These are stadium projects, both in the US. One had a construction or a design time of 20 months, and the other one, half of that, right? I mean, this is kind of just over a period of 5 or 6 years that this is the kind of transformation that we are seeing world over. So what do we do in this case? I mean, if we have just half of the time, how do you deliver that project? So there's two ways that we can take, right? I mean, we can just do less stuff. We can give less information. We can have contractors figure it out or delegate it down the line. That's one way of doing it. But we would rather take on the responsibility, use data-centric modeling to kind of give additional responsibilities so that the risk is less. And that's what is supposed to happen. So now we know the old kind of the waterfall way of delivering structure doesn't work with fast-track projects and where we are headed. So with geometry being the first step, then analysis, construction documents, detailing, then the submittals or shop drawings, erection, drafting, punching. So that kind of one after the other kind of aspect doesn't work anymore, because all that leads to is an inefficient relay race, right? I mean, as a design consultants and architects and engineers, we kind of work in this one green box where we are kind of doing our coordinated design. And then when it goes into construction, we have all these other silos, like the formwork contractor, the rebar, masonry, steel contractors. They're all working in their own thing. And this is not even talking about MEP. So everybody is working in their own little silo. and the only time that the first time they come together is on the field when things don't match. So that's why this digital approach or digital practice or data-centric processes are required. And there's a few different things that what is the need for that? So as was mentioned earlier, things are getting complicated, right? To address this complexity, there's more things that we need to evaluate in more depth. So optioneering is something that we have to do more and more. To reduce waste, sustainability, I think the more the optimized designs are, I think we are reducing waste. Unleash creativity, give more control to ourselves, provide higher levels of fidelity and quality, and deliver consistently. It's not doing just something on one project. So these are the kind of things that require this thing called digital practice. But what is digital practice, right? So we asked these questions to ourselves, what is digital practice? So the answer that we came up within our firm was, it's a firm-wide approach to leveraging information using technology, helping our creative personalities turn knowledge, experience, and innovation into value. I know it's a mouthful, big definition. But actually, when you look at it, a lot of these things are not important. If you take out all the fluff out of it, what remains is it's just leveraging information using technology. And that's what is the critical part if we want to move into the next phase where all the other industries are already there. But more importantly, what digital practice is not, and this is where we all need to be careful. So it's not just blind application of tools. It's not just buying something out of the box and using it for the sake of it. Then you're not getting it done. It's not doing just cool stuff because somebody in the office wants to do it, where it's bringing no value. It's definitely not that. It's not about delivering faster with just a push of a button. We know a lot of young engineers coming from the college, they're getting button pushers without understanding what's actually happening. So it's definitely not that. And it's definitely not producing some deliverables, models, or drawings without any review. So that's not what it is. This actually is a very interesting graph. So PlanGrid actually did a survey of a lot of contractors to understand where they spend more frequently, where they spend more time than what was expected. And some of the usual suspects are there is in communication, project execution and coordination, conflict resolution, design mistakes and rework, organizing job site and people, and looking for project data and information. So some of these things are pretty low-hanging fruit, I would say, right? I mean, these are the things that we as design professionals can definitely control in conflict resolution, detailing mistakes and rework, and looking for data. So this should not be acceptable. Contractors shouldn't have to look for data, which is something that we should be providing, right? So the big question is, the contractor needs 100% of information to build a project. How much information are we providing as design professionals? So this is a question we can ask ourselves. And the answer, I think, ranges from anywhere from 40 to 60% is the information that we provide. There's a lot of stuff that's still not being provided directly. So if you kind of look at it from this standpoint, if the information provided at concept design is like, let's call it 0%, versus construction document, hopefully everything is provided. But what happens is, when we do a drawing, a 2D drawing handoff, then there's a big cliff. I mean, there's a knowledge gap that happens there where all the information that is required from a contractor standpoint to kind of bid the project correctly is not provided. So there's a big bidder understanding. It kind of drops the information, then you have to go back, maybe ask for additional information or make assumptions, and that's why it kind of increases the time and cost of projects. So how do we kind of take care of this loss of data and knowledge? So okay, I'm saying not giving 2D drawings. So can we do BIM? Yeah, but I mean, what are we actually doing when we say building information modeling? If it's LOD or level of detail, if it's at 100, basically you're just doing the space reservation. LOD 200 is the approximate size and location, things like that. LOD 300 is the exact size and location. Okay, now we are getting somewhere. So that's the kind of information that will help the contractor. But the LOD 400, which is kind of a ready-to-fabricate kind of model, is what is actually required. And LOD 500 is kind of the as-built. But at least providing that LOD 400 is what is required. And if you provide this information reliably and on time or before time, that's when there is no gap between the understanding of the bidder and the model handoff. And that's what I think our goal should be. So we looked at the traditional approach earlier, right, where the design is done, and then comes the detailing and construction services where RFIs and things like that. And then that's the completion of your design phase. But what kind of we are looking into with this data-centric approach is kind of something that we are calling connected. So that's transformative integrated delivery. And when I say we are saying it's something that is internal, but a lot of the leading engineering companies have their version of this. So the design happens, and then there's a overlap phase where modeling and validation happens. And there is overlap between the two. And what that does is it's kind of definitely leading into schedule savings. Now you would say, okay, now you're actually cutting down on the design time, but there could be a design extension because this deadline is not going to move. There's more and more. And getting the modeling and the construction engineers who are doing the erection analysis and all those kind of folks early on, in early involvement, there could be a lot more give and take of knowledge sharing that happens between these two phases. And this is not drawings, these are models. So models that can be created early, even a Tekla model created at a schematic design phase if we are using the data correctly. And that's what the goal is. All right, so talking about models, we know in the project there's a lot of models that kind of happen, right? I mean, these are manually generated models prepared by different folks within the life cycle. There could be a parametric model which is used for geometric definition, defining the geometry, and that could be designed by some designers, architectural designer or engineering designers. There's an engineering model, could be SAP or ETABS or something like that, which is done by the engineers. There's a Revit model which happens, which is again, maybe there's some draftsman in the office who are putting together the Revit models, and there's a fabrication model like a Tekla model, something like that, which steel detailers are putting together. But these are kind of created in their own little silos independently. I know there's tools that will kind of transform now from going from Revit to Tekla, Tekla to Revit, and so on and so forth. But then what we are missing is kind of, there's so many other platforms that this information needs to go in. So if we kind of look at Revit and Tekla, like this, so there's only two connectors. We have to be able to go from Revit to Tekla and Tekla back to Revit. Okay, that's good. But now you add the engineering models like SAP and ETABS, and now you need to have two more connectors for the information to go from SAP to ETABS, ETABS to SAP. Now you also want them to be connected to your Revit and Tekla model, so you need 12 connectors for the information to be able to go from one place to another. Okay, that's still kind of manageable, doable. But now you add other stuff like geometric modeling, your Rhino and Grasshopper, your Naviswork, your Power BI tools, GSA, NDM that design fabric. So there's so many happening, so many things happening. And now you have all this mesh of how the data needs to go from one place to other, right? And now you'll almost need an entire IT team just to manage your data on a project. So that's not ideal. So what we've been doing is something called CID, and this is not the CID as what we are thinking about. Daya Tod Darwaza, not that CID. This is Central Interpretability Database, right? So what this is basically data which can be exchanged between all different kinds of models. And so everything is finally connected. And these connections is what helps into actually going where we want to go, where it's a kind of a data-centric process. You don't have to do same thing over and over again. You don't have to go back and change your engineering model because something else has changed, the architect has changed something. So this is what we are kind of trying to do. So this is an example of a stadium in Austin. The one on the left is the engineering model, and the one on the right is the documentation of the Tekla model, a Revit model. So the only model that was prepared here was the one on the left. Everything else kind of was auto-generated, for the most part without any additional manual intervention. And that's what is required. So the model that can be created could be up to a LOD 300 model, which can easily be created if and only if the engineers who are doing the basic first modeling, they know what they're doing. They are modeling things correctly. They know what the orientation of the members are, how the connections are going to be, and all those kind of things. So this is a small video of how this can work, and I don't think we have enough time, but basically, if you have a Revit model on your top right, and you can get the information in this SID, it could be as simple as an Excel spreadsheet, and this information comes in. Now you can go into Grasshopper and Rhino, write your programs to kind of get this information makes geometric changes if and as required, and then that thing kind of moves into your ETABS model. The ETABS model or SAP models or whatever your engineering models are, they design it, go back to your Revit and Tekla models and get all those things get updated. So one thing here is this SID or any of these databases, they are not black boxes. They are open to all engineers so that that data can be queried, that it can be reported in different ways, so it can be actually useful and not doing just cool stuff for the sake of doing it. So I'm gonna move on. So this SID exports, what they can also do is give you a snapshot of your, to track quantities and what was happening at different stages of the project, how does the quantity change or reduce or whatever the case may be. And the other important aspect obviously is sustainability. Are we able to leverage this information, this data, so that we are able to be more sustainable? Are we able to kind of do that? So what we can also do, since we have really good quantities, if you can add in the right factors, we can actually come up with the embodied carbon, not only overall on the project, not only just concrete and steel, but different grades of concrete, different types of steel, your rolled section, your tubes, your deck, how much kind of carbon is kind of consumed in all these different things. And this, to me, is really important. So decisions that the project teams from the owner on down, everybody can make based on how much embodied carbon is being used. So it's not only talking about steel right now, but this is something that we should all be kind of striving to do. Another example of that, same thing, kind of a steel composite structure, and that kind of total embodied carbon, how much was that? What's the contribution from concrete and steel? You can see, okay, if you actually want to make a substantial change, then the steel WT sections and shapes, that's where you need to make the change. So these kind of design decisions can be made early. All right, so I'm going to just take a few more minutes to talk about, is this all just theory or are there actually projects where we are doing this? So I'm going to start with a quick project in Florida. It's Daily Place Jaguars practice facility. And I'm going to go a little quick here for a shortage of time, where this is amphitheater practice facility connected to the stadium, roof structure, something that Populous was the architect. They came up with design. Different options were considered. And then early iterations of primary structures were done. Now you kind of go and back and forth. This is kind of the old way of doing it, which is also important, happens across the table. But what the feedback loop is, what I'm calling it, is what happens is this is where actually the data becomes very important. With Populous, in this case, kind of started with a baseline Rhino model to Waterpy more. And okay, this is what is required to be done on this project. Then we develop a grasshopper model, which is, and then do some sensitivity studies. Okay, this is kind of the areas, what kind of structure is going to be required. And then push that into, push that into a SAP model where we actually run the designs, and then again push that into Grasshopper and Rhinoceros, which are the parametric modeling tools, and give it back to Populous where they can actually review that and okay, this looks good, we need to make these changes. And this is a continuous feedback loop. And this is not exchanging drawings or models. This is happening in real time. And that's where I think the value is. So you kind of start with a parametric definition of the entire structure and what in this case, it was a PTFE roof, and then the primary trusses, bridging trusses, and the columns that are required, all kind of created digitally. You're using the right tools for the right purpose. For the primary steel, maybe getting Rhino or GSA, SAP, Revit. So all these different models are created, but they are all created and connected through this SID. So the information is one central database which kind of collects all this information, and so that they are all connected. We're not independently doing things so that, and then trying to verify whether it works or not. And because this is done early on, early models can be created. Our construction teams can advise, okay, rather than doing this, why don't we do this kind of things? These are the type of connections. So at SD level, a Tekla model can be developed pretty easily. Look at different kinds of connections. Okay, this is what actually works on this project. Discard the rest and move on. And even though models are handled, if there's actual requirement, 3D details can be exchanged, which are much more meaningful than providing 2D details. So that's kind of where the value is. You can also look into construction, where are the shoring towers going to be? All that also can be incorporated in this process. And as a result, what happens is, on this project, there was not even a single RFI that was created. And it was delivered before schedule before time and on less schedule. Okay, so are we able to do things like this in India? Yes, we are. So we actually completed an arena project, a confidential one, which again Populous was the architect. Similar loop. Instead, the starting point on this one that they used was Revit. So we were able to bring value, go back to Populous, and these iterations take place. This is a small kind of solver. I'm just going to show it. Hopefully this works. Yeah. So this is a very, very simple solver that I'm showing right now in parametric modeling, how manually for design of a truss you can change the depth and shape and number of bays and all those kind of things. But then you can add parameters. Okay, this is my sight line is going to be affected from here. So what are the different things that can be done? And the program can actually design all these things. If you add Karamba as another kind of tool to it, you don't even have to spit it out to a software like SAP, but it designs internally within that and then come up with a solution that really works. So this obviously is not what the truss looks like. This is what it looks like. On the left is where we started from sight lines perspective, how it changed, the various iterations. Unfortunately, on this project, because of the contractual relationship and what our scope was, the unfortunate thing is even though we had a model, what was delivered was kind of just a 2D drawings with things. So this is what we need to change. And is this only good for big structures like stadiums? No, obviously not. This is kind of a composite steel design building structure where the quantities starting at SD level can be tracked at different portions, the concrete, the shear walls, steel. In steel also, what's the quantities for columns, braces, beams, deck, trusses, everything can be tracked starting at SD level. And the important thing here is you can kind of do that comparison, what was at SD level and what was at the GFC level. You can actually do that and use the SID to kind of look into those different things and see what actually changed. How many number of members actually had to be added? What did the tonnage go up? And not only that, but which were those members? So we can query that, use our models to actually highlight what the changes were, kind of find that out electronically, and then locate them. Okay, these are the members that changed or were added. And then say, okay, these are the different reasons why those members had to be added. So we need to be able to use this data, not just do stuff for the sake of doing it, but it has to bring value to it, and this is one way of doing that. And it can be represented in a Power BI report showing how different things, what are the things that changed, and so on and so forth. All right, I've been talking quite a bit. So wrapping up. So what I want to kind of get at is, we know how we do things the old way and what's the new way. So what we need more than data is a change in the attitude. We need to think of ourselves as something different. We can't just say that, okay, we create drawings. No. We don't even create models. We create data. That's kind of the thought process that we should have. We shouldn't have to think our drawings are accurate enough, the contractor we will be able to build from it or something like that. No, we can't have that attitude. Our models need to be machine readable and fabrication friendly. So that's kind of where we are headed. We work with our software. No, this is not the software, but the software that is required by the client, maybe the software or whatever is required by your other project delivery partners. So that's what we should be thinking about. To me, this one is really important. Sharing information is risky. We used to think 10 years ago, okay, I'm going to share my model, and L&T is going to use it, and they're going to see, okay, your model had something different, and now you're making a change. I think not sharing model is risky. We should be working as a team, and so not sharing information is where the risk is. We should be risk averse in that case. And rather than thinking ourselves as structural engineers, it's an integrated team, and which can solve the project's problems in a virtual way. So that's where I wanted to kind of talk to you about. So what's next? Well, somebody said ChatGPT earlier, right? So I know everybody in the room knows what ChatGPT is. Do you think that ChatGPT can design a building by show of hands? Maybe two people think, maybe people think it's 5 years. It's happening right now. You can actually say, I want to design a 3-story building, C-shape, these many levels. It's happening right now. There's a company called TestFit. If you have a plot of land, they can tell you actually what is it that you can build on that land. If you want to build a hospital, this is what you can do. Within like seconds, not even minutes. You can have thousands of options that you can use your land. So this is happening now. So we need to kind of transform ourselves to kind of do these kind of things. Emulators, right? I mean, where you're using kind of AI and ML to kind of come up with, so let's say foundation design or column design. You teach the machine, okay, these are thousands and thousands of ways a foundation was designed for this size, this load. You don't have to design it anymore. It can tell you, okay, this is my load, okay, this is what it's going to be. So that's where it's headed. It's already started. So we need to kind of do the catching up here. So AI, ML, it's been in the news quite a bit, but it is powerful tools if we know how to use them. And the other part of it is we need to change. So my colleague and partner Abhishek is here. He's only 5 years younger to me. He's much better in doing these things than I am. We have engineers in our office who are less than 20 years, 25 years old. They are 10 times better in understanding and doing these things. So people, engineers, everybody is demanding it. There's need for it. So we need to change. So don't be this guy who's really, I don't want to change. Don't be this guy. Be these guys who actually want to and kind of do the change. Let's be the change. And so transforming steel design using technology, I think the future is now. So we need to start working on it right now. I think we're not going to take questions right now, but at 4:15, I'm going to do a plug for a panel discussion that we're going to be doing today, and we're also going to be looking at how it's affecting not only the design, but construction of it. And we have an extremely good panel, so looking forward to it. Thank you all.